guys, how are you doing today? I want to show you where the equation with quadratic speeds comes from. So the equation I'm talking about is this one up here. So this equation is basically just relating velocity, initial velocity or just simply v naught, and the change in distance or displacement and acceleration. Now something very cool about this equation and that, well, makes it different from all the other equations that we know is that it does not involve time in its structure, okay? We do not need time in here so that we can find any of the values that you can see here. So the derivation is as follows. So we're going to start off by finding acceleration. Now we know acceleration as a vector, remember, is the change in velocity over time. And now we know the change in velocity is just simply final velocity minus v naught, okay? Any type of, well, not any type of, any number that represents our initial velocity over time. Now, something we want to do is that from this equation, we want to take out time, okay? Remember that our end goal, to some extent, is to not have time in this equation. So we cannot have time in this fraction right there. Now, how much is time equal to? If we take our three cousins in kinematics, we know that velocity is equal to displacement as a vector, this is also a vector, over time. Now here we're saying this is the average velocity. And we also know that average velocity is also equal to final velocity plus v naught over 2, okay? Now this means that we can, from these two equations, we can say that v plus v naught divided 2 is also equal to, I'm going to start saying that this is the change in x, okay? I think it's a bit more, maybe not concise, but maybe it looks clear for you. So we're going to have, this is change in x over t. And now in this case, we just need to find t, okay? Because remember, we're trying to write t in terms of other variables. So here I'm going to cross numerators and denominators. So we're going to have t times v plus v naught is going to be equal to 2 times change in x. And so we're going to get from here that time is equal to 2 times change in x divided by velocity plus v naught. So that is how much we get. And now we can plug in this equation into t, or well, this expression into t in here. So we're going to have that this is v minus v naught over 2 times change in x over v plus v naught. Okay, if you don't know why I'm saying v naught, when you have v sub 0 or v sub o, depends on, well, whatever you want to put in there, you said that as v naught, okay? I didn't know that when I first heard the word v naught, so, well, I thought it might be useful for you to know that this is v naught. And now we know this is, this division, we can simplify it as multiplying by the inverse of the denominator. So we're going to have that this is v plus v naught times v minus v naught over 2 times change in x. And so we get this. Now you might see up there we've got a difference of squares, okay? This is the same as if you had a minus b, a squared minus b squared. You just simply multiply the conjugates of that expression, or you switch the sign, and that is exactly what we have up there. So this is a difference of squares. I'm going to write it in the form a squared minus b squared. So you know what I did up there, because I'm not going to FOIL. I'm just going to say that this is v squared minus v naught squared, okay? And this is just going to be 2 delta x. So we know all this is acceleration. So now let's see it. So we have acceleration is equal to v squared minus v naught squared divided by 2 times change in, oh, that looks so awful. 2 times, I'm sorry, 2 times change in x. And now the standard form, this is the equation, okay? This is the equation, but in a different form. If you want to write the equation in the most common form, which is the one up here, well, now you just gotta play with each expression. So in this case, we're saying velocity is equal to 2 terms, which is initial velocity and acceleration times change in x. So that's what we're gonna do. So we're gonna solve for v squared. So we're gonna have that v squared minus v naught squared is equal to 2 times acceleration times delta x, okay? I just switched the order of the factors, this should be like 2 delta x, but it's the same as if we said 2 times acceleration times delta x. And now this is just going to give us v squared is going to be equal to v naught squared plus 2 times acceleration times delta x. And this is the exact same equation that we have up here, okay? So this is the entire derivation. I hope that you see what we did. In physics, the cool thing is that everything is equal to everything, and pretty much that idea is the same in math. What I'm saying is that one thing, such as time, you can represent it in, well, a handful of other things, such as all these equations that we have, in here, okay? And at the end of the day, well, you can build a lot of different equations from just knowing that this is equal to this, and this at the same time is also equal to this. So, well, I don't know, I think that is pretty cool, okay? And that's what basically allows us in physics to build equations like this and just, you know, get some background of, well, the equations that we use in problems. So I hope you guys enjoyed this video and see you in the following one.